Welcome to Basic Thermodynamics class. We are discussing Chapter 2 Thermodynamic Process. So, subtopic is entropy of gases. In that entropy of gases, we are solving problems based on a different thermodynamic process of change in entropy. Before solving the problems, we will discuss what are the formulas we discussed in the previous class. So first, what is an entropy? So the entropy is nothing but as one change in the thermodynamic process, and that entropy depends upon only the end states and independent upon the path of the process. So here the entropy for the closed system, we are defining that it is an integral of the heat transfer to the absolute ratio for any reversible process between the states. So mathematically we are writing ds represents the change in entropy. ds represents change in entropy is equal to integral dq by t. And we can write this equation also, S2 minus S1 is equal to Q122 by T, where Q122 is called as a heat supplied or rejected to the system. So the units is a kilojoules and T is called an absolute temperature in Kelvin. So by using this formula, we can tell that the entropy can be changed due to the several aspects. The first point is that here the entropy is directly proportional to the heat transfer. If you remove the heat, means if you are removing the heat to the system, the entropy will decreases. If you supply the heat to the system, the entropy will increases. The first point tells that the entropy will decrease when the heat is removed, and entropy will increase when the heat is supplied to the system. And the second point is that here we have to one main important thing is that for the adiabatic process the heat transfer is zero. If the heat transfer is zero, if you put the here 0, so change in entropy is equal to 0 by temperature. So 0 by anything is in a 0. So what it is telling that the entropy will remains constant for a reversible adiabatic process. So that's why the reversible adiabatic process is sometimes referred as an isentropic process. So why? Because here in adiabatic process the heat transfer is 0. So 0 by temperature is 0. So the change in entropy ds is equal to 0. So S2 minus S1 is equal to 0. So S2 is equal to S1. S2 is equal to S1. This is for the reversible adiabatic process. So if it is the entropy of an isolated system will increase when irreversible process occur with it. Irreversible process occur with it. So these are the three accepts for the entropy change are these 3 points. And next the units of the entropy are we know that the formula is a q by t. For the q it is in a kilojoule and t is in a Kelvin. So the units are kilojoule per Kelvin, or if you take the q in terms of a joule, you can write the unit also as joule per Kelvin. Joule per Kelvin. Next we will discuss the change of entropy during various thermodynamic process like constant temperature, constant volume, constant pressure, adiabatic process and the polytropic process. So the change in entropy related to the mainly primary properties such as a pressure, temperature and the volume. So there are the different process for the change in entropy. So we are discussing first process is a constant volume process. So for the first constant volume, what it is telling that if you consider the mass m, the gas is heated. Here the mass m kg of gas is heated at constant volume, and here the entropy depends upon only the state 1. So heated from at constant volume from state 1 to state 2. So the constant volume delta S at delta S is represented as a mcv ln T2 by T1. So this equation can also write in as a mcv ln P2 by P1. Why? Because at constant volume process, this equation can be written also as a T2 by T1 is equal to P2 by P1, because we are keeping volume as a constant. So temperature is directly proportional to the pressure. So here you are considering the two state 1 and state 2. That's why we are writing as a 1 and 2. So T2 by T1 is equal to P2 by P1. So whatever the area under the curve of TS diagram, so the TS diagram represents as a curve. So the area under the curve 1 to 2 represents the heat transfer during the constant volume process. Constant volume process. So this is the formula. In one more question they will ask, write the two formulas for them change in entropy during the constant volume process. So the constant volume is, if you the name itself indicates, you have to put here as a CV. So delta S is equal to mcv ln T2 by T1 is equal to mcv ln P2 by P1. ln is nothing but the log base E. ln is nothing but log base E. We can write ln or log base E. The second formula, the change in entropy during constant pressure process. So this process is also called as an isobaric process. The TS graph is also same like a like a constant volume graph. It is also the curve. So the TS diagram for the constant pressure process, whatever the area under the curve 1 to 2 represents the heat transfer during the constant pressure process. So here we are taking as a pressure as a constant. So then the delta S we can written as a mcp ln T2 by T1. Delta S is equal to mcp ln T2 by T1. Here we are taking the pressure as a constant. That's why we can write the T is directly proportional to the volume. T2 by T1 is equal to mcp ln V2 by V1. ln V2 by V1. We call this process is also called as an isobaric process. Isobaric process. And here the if you draw the graph between TS diagram for the constant pressure and constant volume, we will observe that the slope of the constant volume line is greater than the slope of the constant pressure line on TS diagram. The change in entropy at constant pressure will be larger than at a constant volume between the given temperatures. Thus that the slope of the constant, thus we can tell that the slope of the constant volume line is greater than the slope of the constant pressure line on TS diagram. So this is also very important. So what is in which case the entropy is more at constant temperature or the constant pressure, they will ask. So since the Cp is greater than Cv value, we know that the Cp value is greater than Cv value. So the entropy change at constant pressure, here the Cp value is greater than the Cv value. So these product, if you take the same values of a T2, T1 and M, and Cv and Cp are different. In the first two formulas, Cv and Cp are different. So Cp is greater than the Cv. That's why we can tell that the change in entropy at a constant pressure will be larger than the change in entropy at a constant volume, maintaining the same given temperatures. Here in both the conditions we have to maintain same temperature conditions. If the temperatures are different, we can't tell which in which process the entropy is more. Here we are, the one note is that here we are telling that here we are maintaining both the temperatures are same in both the process, and the mass is also same, but the varying is the Cp and the Cv value. If the Cp is greater than the Cv, that's why the change in entropy during the constant process is greater than the change in entropy during the constant volume process between same given temperatures. Same given temperatures. So this one. Next, the change in entropy during the constant temperature process. This is also called as an isothermal process. So in isothermal process, what we know that, so whatever the amount of heat transfer Q at constant temperature is equal to the work done during the isothermal process. Work done to the isothermal process. dq is equal to dw. Here the internal energy is a 0. So the change in entropy for the isothermal process we are writing as a mr ln v2 by v1 mr. So here dq is equal to, we write mrt log v2 by v1. We know that the dq is equal, ds is equal to dq by t. So here the numerator temperature and the denominator temperature will get cancelled, and simply we will write delta S is equal to mr ln v2 by v1. So we know that the Q is equal to heat transferred during the isothermal process, it is MRT ln V2 by V1. Here change in entropy delta S is equal to dQ by T. So in dQ 1T is there and the denominator 1T is there, T will get cancelled and the remaining is MR ln V2 by V1. And this equation also we can write as a MR ln P1 by P2. Why? Because here that the volume is inversely proportional to the pressure. As the volume is increasing, the pressure is goes on decreasing. Here pressure is goes on decreasing. So the temperature T1 is equal to T2 and it is represents as a horizontal line. In TS diagram it represents a horizontal line. So whatever the area under the line, here the TS diagram, in these two cases that the graph of the TS is a curve, and in the case of a temperature it is a line. So whatever the area under the line represents the heat transfer which is equal to the work done during the isothermal process or constant temperature process. So we have to remember that in the first two process the TS diagram is a curve and the third one it is a line and it is in a horizontal line. It is in a horizontal line, and in the fourth one is also the TS diagram is in a vertical line. And here they given change in entropy for the adiabatic process. Already we discussed that delta S is equal to 0 because in the adiabatic process, there is no heat transfer takes place, so therefore the change in entropy is 0. So hence we call it as an isentropic process. And the adiabatic process is represented by a vertical line. Adiabatic process is represented by a vertical line, that is S1 is equal to S2 because S2 minus S1 is equal to 0. That's why S1 is equal to S2, or we can write delta S is equal to 0. So in the first two process the TS diagram is a curve and the value of a change in entropy at constant pressure is greater than the change constant volume process, and at constant temperature process T1 equal to T2 and represents a horizontal line, and in the change in entropy T1 no heat transfer is takes place, that one S1 is equal to S2 and it represents as a vertical line. So this is all about the constant volume process, constant pressure process, constant temperature and the adiabatic process. So we have to remember all these formulas to solve the problems, and in 1 mark question and the 3 marks question also they will ask, write the formulas for the change in entropy during the constant volume, constant pressure, constant temperature and adiabatic process. So we have to write all these formulas in for the 1 mark question. If they will ask, write two formulas for the constant volume process and write two formulas for the constant pressure process, or write two formulas for the constant temperature process. So you have to remember the two formulas, and if you remember the two formulas while solving in the problems, if the given in data if they given the data in terms of pressure, substitute this formula. If they given the data in terms of temperature, we can substitute delta S is equal to mCv ln T2 by T1. So depends upon the formula, depends upon the problem, you have to select one formula. Next we will move on to the polytropic process. So polytropic process. So here the entropy change in terms of a volume. Here the entropy change in terms of a volume, we can writing delta S is equal to mCv gamma minus n ln V2 by V1. V2 by V1. Or we can write this Cv as a R by n minus 1. R by sorry, gamma minus 1. It is not n minus 1, it is an a gamma minus 1. It is not n, it is an a gamma minus 1. We all know that the CV value is a CV value is equal to R divided by gamma minus 1. The change in entropy in terms of a volume. And if you remember one formula, it is easy to write the change in entropy in terms of pressure, in terms of temperature also. So first remember these formula only. So if you remember this formula, by simplification we will get all the formulas. So we know that the CV is equal to R divided by gamma minus 1. So simply I am substituting here CV is equal to R divided by gamma minus 1. Then the formula becomes MR gamma minus n divided by gamma minus 1 ln V2 by V1, where R is the gas constant value, gamma is an adiabatic index value, n is the polytropic index. So the same formula, I am using these formula only. So I am writing the in terms of a pressure. How I will write? It is in a polytropic process. We all know that the equation PV power n is equal to constant. PV power n is equal to constant. So we can write this equation as a P1 V1 whole power n is equal to P2 V2 whole power n. So here we have to delete this volume and write in terms of a pressure. So I am writing this V2 by V1 as a V2 by V1 as a V2 by V1 as a P1 by P2 whole power 1 by n. V2 by V1 as a P1 by P2 whole power 1 by n. So that's log A power m become as a 1 by m log A. So this will, in terms of a pressure, it comes like a, here P1 by P2 it becomes whole power 1 by n. So it comes to here, it like a log A power m. How is m log A? Log A power 1 by n. 1 by n log A. So like that MCV gamma minus n by n log P1 by P2. So this is in terms of a pressure. Next, like that only in terms of a temperature also. So we all know that V2 by V1 is equal to, we know the relations between P, V, T. So by using that relations, I'm changing the formulas like this. So we all know that V2 by V1 is equal to T1 by T2 whole power 1 by n minus 1. Whole power 1 by n minus 1. So that n minus 1 come to the denominator side. So delta S is equal to MCV gamma minus n divided by n minus 1 ln T1 by T2. So if you want to change this CV also, we can change. CV is nothing but R into gamma minus 1. R divided by gamma minus 1. R divided by gamma minus 1. So in numerator there is one R is present, denominator gamma minus 1 is present. So no need to remember all these formulas. Simply remember one formula, MCV gamma minus n ln V2 by V1. So by using the relations of a P, V and V and T, we can simplify these formulas into the pressure and the temperature also. So these formulas are also very important in the 3 marks and the 1 mark question also. Simply they will ask the write the expressions for the change in entropy during constant volume process, constant pressure process, constant temperature process. Otherwise they will ask, so constant volume process is also called a isochoric process, pressure as a isobaric, temperature as a isothermal process. So they will ask like that also. So at constant volume temperature process, and here the polytropic process in terms of a volume, pressure and the temperature. So these are the, they will ask in 1 mark question, or in the problems based on the data we can use whatever the data is there. If they given data in volume, we can use this formula. If they given the pressure, you can use this formula. If they given the temperature, you can use this formula. So first you have to remember these formula. Automatically these two formulas will get by simplification of P, V and T. Next, there are some expressions considering here both P1 V1 and a combination of two, pressure and volume, temperature and pressure, volume and pressure. Here the change in entropy in terms of a temperature and volume. So the change in entropy S2 minus S1 or delta S is equal to mCV ln T2 by T1 or ln V2 by V1. So you have to remember these formulas also. So temperature and volume. So temperature and volume, M is a common, CV ln T2 by T1 plus R ln V2 by V1. And temperature and pressure. So mCp ln T2 by T1 plus, sorry, here it is a minus, not plus, minus Cp delta S is equal to mCp ln T2 by T1 minus R ln P2 by P1. Next, the change in entropy in terms of a pressure and volume. Delta S is equal to mCv ln P2 by P1 plus Cp ln V2 by V1. So these formulas also we have to remember that, because the combination of change in entropy during temperature and pressure means at at constant temperature and constant volume, nothing but the constant temperature and constant volume. So this is mCv ln T2 by T1. It is a constant volume process, and mR ln V2 by V1 is in a constant temperature basis. So combination of a constant temperature and combination of a constant volume basis. Here constant temperature. So we know that the constant temperature is a mR ln. If you take in terms of a pressure, it is a P1 by P2. But here I am writing as a minus. That way it becomes minus R ln P2 by P1 Cp ln T2 by T1. Next, in terms of a pressure and in terms of a volume. So, in terms of a, this one is a volume, Cv ln P2 by P1 plus Cp ln V2 by V1. This is nothing but the combination at constant pressure and constant volume, constant temperature and constant pressure and constant volume. Just you have to combine both the equations. So already 1, 2, 3, 4, we already know the relations. So it is the constant pressure mR ln V2 by V1. So this is one is a constant temperature, and constant volume is Cv ln T2 by T1. CV constant volume means that by CV. So M is the common. So I am taking M as a common. CV ln T2 by T1 plus R V2 by V1. The formulas is the combination of a constant temperature, constant pressure, constant volume. Constant pressure and constant volume, constant temperature and constant pressure. So you have to write this the combination, or otherwise you in the problem, if in the problems they will ask, you can find separately and finally calculate what is the change in entropy during both the process. In theory question or the 1 mark or the 3 marks, write the relation between the change in entropy in terms of a temperature and the volume. So we have to write this a combination of a constant temperature and the constant volume like this. So these are the three formulas for the change in entropy in terms of a temperature, volume and temperature and pressure. Third one, pressure and volume. So then next there is the approximation for the heat transfer. So Q is equal to T1 plus T2 by 2 into S2 minus S1. So if the temperature increases from T1 to T2, approximation of the heat transfer you can write as a T1 plus T2 by 2. The formula for the approximation of the heat transfer. Q is equal to T1 plus T2 by 2, average of the temperatures, and S2 minus S1. So we in this we can calculate the, if they given the heat transfer and the temperatures, we can calculate by using the formula this change in entropy. S2 minus S1 is equal to Q divided by T1 plus T2 by 2. So we will solve some problems based on these formulas. The first problem, 0.05 kg of gas is heated from 250 degrees centigrade 250 degrees centigrade to 150 degrees centigrade. Calculate the change in entropy. If the process is carried out constant volume, take the CV value of the gas 0.9 kilojoule per kg Kelvin. So here they mention that it is it is not 2, it is a C. 250 degrees centigrade, and they mentioned it is a calculate the change in entropy at a constant volume. Just I am highlighting. So what is the condition here they given? It is in a constant volume. Change in entropy. So they given the temperature values. So we know that if they given the temperature values and M value also, CV value also, so change in entropy during the constant volume is M CV ln T2 by T1. That is the formula for the change in entropy during the constant volume process. So first write the given data. So mass 0.05 kg, 250 degrees centigrade temperature, next 150, it is not 250, it is an 25, sorry, 25 plus 273, it is 298 Kelvin. So 25 plus 273 is a 298 Kelvin. Final temperature 150 plus 273, 423 Kelvin. Next, what's the given the CV value? CV is equal to 0.9 kilojoule per kg Kelvin. So we know entropy during the constant volume process. We know that the change in entropy during the constant volume process delta S is equal to mCV ln T2 by T1. So why we are taking the formula in terms of a temperature? Because in the problem they given the data temperatures T1 and T2. That's why we are taking the formula delta is equal to mCV ln T2 by T1. In the problem, if they mention the pressures, in the pressures, so we can take the formula delta S is equal to mCV ln P2 by P1. Based on the problem, so we have to write the formula, either it is in a pressure or temperature. Here we are considering the temperature only. So that's why the delta S is equal to mCV ln T2 by T1. So all the data are given in the problem. So substitute in the formula, m value given, CV, T2, T1. So delta S is equal to 0.05, CV value 0.9, ln 423 divided by 298. So it should be necessary to convert the degree centigrade into the Kelvin. So first calculate ln 423 divided by 298. Next, that multiply into 0.9 into 0.05, we will get delta S. So here we are taking the C value in kilojoule per kg Kelvin and the temperature in Kelvin. That's why the unit is kilojoule per Kelvin. 0.0162 kilojoule per Kelvin is the change in entropy during the constant volume process. That's the second problem. 0.5 kg of air is expanded isothermally until its final volume is 50% greater than its initial volume. If the temperature of the air is 650 degrees centigrade, calculate the change in entropy during the process. So here what they given the condition, it is an expanded isothermally. So isothermally means constant temperature. So we have to find the change in entropy during the constant temperature process, and the formula is a delta S is equal to mR ln V2 by V1, and they give and write the data that the final volume is 50% is greater than that of the initial volume, the final volume. So V2 is 50% greater than V1. So it is a 150 and 1.5 times of V1. Initial volume we take as a V1 and the final volume as a 1.5. V1. So V2 by V1 is equal to 1.5. So if the temperature is rise to 650 degrees centigrade, so temperature T is equal to 650 plus 273, change in entropy during the process. R value 0.29 kilojoule per kg Kelvin. So first write the given data. Mass of the air 0.5 kg, initial volume V1, the final volume is V2 1.5. So the change in entropy delta S is equal to MR ln V2 by V1. So 0.5 into 0.29 ln. Here the V2 they given there is a 50% greater than the of initial volume. So 50% is greater than means 100 plus 50 150. So 150 divide percentage they given. So 150 divided by 100. So it was a 1.5 V1. So we will get V1 get cancelled. V1 and V1 will get cancelled and the remaining is ln V1 get cancelled and the remaining is ln 1.5. So calculate ln 1.5 means log base E 1.5 into 0.29 0.5. So delta S is 0.0588 kilojoule per kg Kelvin. So this is the change in entropy during the isothermal process or the constant volume process 0.0588 kilojoule per Kelvin. Here is the same problem. In this problem, they given is they change only the mass value. So 1 kg of air is expanded isothermally. Is the initial final volume is 50% greater than of initial volume. The temperature is 55 degrees centigrade. Change in entropy during the this process. The same problem here the mass only change. So first write the data. Mass 1 kg. Initial volume V1 is the final volume 50% greater than the V1. So it is 1. So change in entropy during the isothermal process delta S is equal to MR ln V2 by V1. Substitute all the values, we will get delta S is equal to 0.1176 kilojoule per Kelvin. The same problem, just only the mass change. In the previous problem it is 0.5 kg. In this problem 1 kg. So just we'll move on to the next problem. 1.36 kg of oxygen at 103.4 kilonewton per meter square and 15.5 degrees centigrade is expanded at constant pressure. So they given the condition it is in a constant pressure until its volume is expanded, until its volume is doubled, calculate the final temperature, work done, change in entropy, assume the Cp value for the oxygen. So in the this is important for the 5 marks problem. In this problem they want to calculate final temperature T2, work done dW means at constant pressure and the change in entropy during the constant pressure and they given the Cp value. So first write the given data. Mass of the oxygen M 1.36 kg, initial temperature 15.5 plus 273 is equal to 288.5 Kelvin. 15.5 plus 273. Here I am converting the degree centigrade into absolute temperature in Kelvin. So by adding the 273 we will get the absolute temperature. And they given that the volume is doubled. So initial final volume is doubled of initial volume. So V2 is equal to 2 V1. So we can write this as a V2 by V1 is equal to 2. Calculate the final temperature. And they didn't given the R value also. So we can, they given that the gas is an oxygen. So will you calculate for the gas constant, universal gas constant R is equal to RU by M. So universal gas constant RU we know that it 314. Molecular weight of oxygen is a 32. So we will get the R value as a 0.2598 kilojoule per kg Kelvin. So it is very important that you don't take this as a R is not the fixed for all the gases. RU is a universal gas constant. RU is a fixed value. It is an 8.314. But the R value, characteristic gas constant, is a different for the different gases. So we have to remember that formula. R is equal to Ru divided by M. M is a molecular weight of the particular gas. So here what they given here is the oxygen. So molecular weight of the oxygen is 32. So R value we have to calculate by using the formula. R is equal to Ru by M. Ru is a 8.314, molecular weight 32. So we'll get the value as a 0.2598 kilojoules per kg Kelvin. So first as the final temperature. So at constant pressure process, the temperature is directly proportional to the volume. So T2 by T1 is equal to V2 by V1. T2 by T1 is equal to V2 by V1. So they given the initial temperature and the ratio of the volume. Final volume is equal to the double of the initial volume. So V2 by V1 is equal to 2. So T2 is equal to V2 by V1 into T1. So T1, V2 by V1 is got the 2 into 288.5. So it is an 577 Kelvin. If you want in degree centigrade, simply subtract the answer, subtract the absolute temperature with minus 273, we will get the temperature. This one is in absolute temperature, that is in 577 Kelvin. So we got the temperature at constant pressure process. Work done. So work done during the constant pressure process is P into V2 minus V1. P into V2 minus V1 or MR T2 minus T1. Here we are taking these formula because we don't know the V1 and V2 separate values. We know the relation between V2 by V1. V2 by V1 and the didn't given the pressure value also. So alternate formula is there. So we can write the P as a MR and V2 MR T2 minus T1, MR T2 minus MR T1, MR as a common and in bracket T2 minus T1. So this is very important. So we have to recollect what the formula we have to apply here. First generally we will think of, so no data is given. So we think that the data is insufficient. Not. The data is sufficient. We have to think alternate formula. Here the PV2 we can write as a MR T2 and MR T1. So MR taken as a common. So MR T2 minus MR T1. Take MR as a common, T2 minus T1. So mass they given value and R we calculate. T2 previously we got 577, T1 they given in the data. So work done is a 101.9 kilojoules. 101.9 kilojoules. Next, change in entropy during the constant pressure process is MCP ln T2 by T1. Here we can write as a V2 by V1 also. We can use both the formulas, we will get the same answer because we know the V2 by V1 as a ratio. M value is there, CP value is there. So students try with this formula, you will get the same answer. So because we have the data, if the data is there for the two, we can use any one formula. Delta S is equal to M CP ln is nothing but log base E, log V2 by V1, V2 by V1 because the temperature is directly proportional to the volume. So here I am writing this a T2 by T1 as a V2 by V1. So we know the ratio of V2 by V1 is a 2. So M value we know, CP value is the same. So we can use both the formulas. We can use both the formulas. We get the same answer. So I am trying with this formula. The students you can try with this MCP ln V2 by V1. So you can apply any one formula, but both the answers should be, will get the same answer. So delta S is equal to 1.36 1005 ln 577 by 288.5 is nothing but the 2 only. So the same answer we will get. So delta S is equal to 0.947 kilojoule per Kelvin. So this is a change in entropy during the constant pressure process. First write the given data and calculate the R value by using the RU is equal to M, and you know you have to remember that the universal gas constant value 8.314 and the molecular weight of oxygen is you know 32. So from that we will get the R value, and constant pressure process the temperature is directly proportional to the volume. So T2 by T1 is equal to V2 by V1. From there, we can find the final temperature. After finding the final temperature, we move on to the next bit. Work done during the constant pressure process, W is equal to P into V2 minus V1. So, in there we don't know the P and the V2 and V1 values. So, alternate formula is there, W is equal to MR T2 minus T1. So, we know the M value, R value, T2 value and T1 value. Substitute all the values in the formula, we will get the W value. Next, change in entropy during the constant pressure process. Delta S is equal to mCp ln T2 by T1, or we can use delta S is equal to mCp ln V2 by V1. Substitute all the values in the formula, we will get the change in entropy during constant pressure process, that is 0.947 kilojoule per Kelvin. Next problem. A certain gas Cp 1.973 kilojoule per kg Kelvin and Cv value 1.511 kilojoule per kg Kelvin. Find its molecular weight and gas constant. So we have to calculate capital M value and capital R value. So gas at constant volume chamber, this is a given, it is in a constant volume. It's a constant volume chamber, constant volume process, 0.3 meter cube. Capacity contains a mass 2 kg of the above gas at 5 degrees centigrade. It is not 50 degrees centigrade, it is a 5 degrees centigrade. Heat is transferred to the gas until the temperature is 100 degrees centigrade, not 1000, it is also a 100 degrees centigrade. 100 degrees centigrade. Calculate the initial and the final pressures and the change in entropy. To calculate the initial and final pressures P1 and P2 and change in entropy during the constant volume process. First, write the given data. Specific its Cp value, Cv value, gas constant. There is the problem is also gas constant. R is equal to Cp minus Cv. We all know that R is equal to Cp minus Cv. So 1.973 minus 1.511 is equal to 0.462 kilojoule per kg Kelvin. So there is the molecular weight also. How will you get the molecular weight? By using that the R is equal to Ru by M. R is equal to Ru by M. And you have to remember that it's a Ru value. Ru value that you want M value. So M is equal to, we can write the formula as a Ru by R. So 8.314 divided by 0.462, it is an 18. So the molecular weight of the gas is 18. So the first they asked the calculate R value and molecular weight. So we got both the values. Next write the initial pressure P1. So how will you get the initial pressure P1? So we know that P1 V1 is equal to MR T1. So from that I am writing P1 is equal to MR T1 by V1. So we know the M value, R value, T value and V1 value. Substitute all the values in the equation, we will get the pressure P1 value. So the pressure P1 is equal to 856.24 kilonewton per meter square. So by using the ideal gas equation, P1 V1 is equal to MR T1. So P1 is equal to MRT1 by V1. Substitute all the values in the above formula, we will get the initial pressure P1 is equal to 856.24 kilonewton per meter square. Calculate the final pressure P2 for the constant volume process. P2 by P1 is equal to T2 by T1. So P2 is equal to 856.24, 373 by 278. We will get the pressure P2 value. After that, the change in entropy delta S is equal to mCv ln T2 by T1, or we can write the mCp ln P2 by mCv ln P2 by P1 also. We will get the same answer. So students, you can try this with a mCv ln P2 by P1. You will get the same answer. Delta S is equal to 0.89 kilojoule per Kelvin. Kilojoule per Kelvin. So the first one, first read the question carefully and write the given data and write what they will ask and write the formulas related to that process. So in this problem they given first to calculate the R value. How will you calculate the R value? Cp and Cv. They given Cp value and Cv value. So R is equal to Cp minus Cv, and then next calculate the molecular weight. M is equal to Ru by R. You have to remember that the universal gas constant value, and next R value we got from Cp minus Cv. From that we will got the molecular weight as 18, and next initial pressure. How will you get the initial pressure? By using the ideal gas equation, P1 V1 is equal to MRT1. We can write this equation as a P1 is equal to MRT1 by V1. So we got the pressure P1. And how will you get the final pressure? At constant volume process, P2 by P1 is equal to T2 by T1. So P2 is equal to 1148.84 kilonewton per meter square. So change in entropy during constant volume, we can use two formulas, MCV ln T2 by T1 or MCV ln P2 by P1. So students, you can try with MCV ln P2 by P1. You get the same answer. Delta S is equal to 0.89 kilojoule per Kelvin. So in the next class we will solve some more problems based on, today we will solve only constant temperature, volume, pressure and the pressure process. In the next class we will solve the polytropic process and the change in entropy during the polytropic process.